Hi there guys, this is Miss Nelson here. We are going to go over today our Chapter 3 review test. That's the one that's in the back of the book. It's just a practice test to help you get to know what the real test is going to be like. Like all the other Think Central Go math tests, we start off with vocabulary. Now remember, you have many resources for learning your vocabulary. We go over them at the beginning of every math lesson every day in class. You can take your math book home with you and look in the glossary or in the lesson and find the definitions for the words. Or you can also use Think Central online and go to your library and get your student edition of your math book. So starting off with number 1, a blank is a number sentence that shows that two amounts are equal. Your keyword here is equal. Anytime you have an equal sign in the math sentence, it is an equation. Remember, it's called an expression if it does not have the equal sign. A blank is a mathematical phrase that contains numbers, variables, and operation signs. So if it has 4 plus a equals 7 or whatever it is, if it has a number, some kind of math, equal sign, and a variable, that's called an algebraic expression. Algebraic because it has a variable in there. All right, now number 3 and numbers 4, we're supposed to write the expression to match the words. So we have to change the words into a math expression. Remember, an expression doesn't have an equal sign, so it's just the first part. We don't have to find the answer. We just have to write the math. So Cindy shares 18 marbles equally. Shares equally, we've been working on our math words, and we know shares equally is division. She shares 18 equally among 3 friends. That one's pretty easy. 18 divided by 3 is our expression. Number 4, Kendra had $30, period. So the first part of this is $30. Then she spent, so spent tells me I'm going to do some subtraction. She's starting out with $30 in her hand, but then she has to pay for some things. And there's 2 things that she has to pay for. That means I'm going to put those 2 things inside of parentheses. Because here's her $30 in her hand. Then she has 2 things she's buying at the store. First, she's buying some lunch for $7. And, there's my second math word, and means add. And she's buying books that cost $13. So remember, when we go to the store, at the cash register, they start scanning all your items and they're adding up everything that you buy, and then you have to give them your money. So you take that much of all the stuff added up, you take that away from however much money you came into the store with. She came in with $30 and she spent the $7 on the lunch and the $13 at the bookstore. So our expression should read 30 minus, parentheses, 7 plus 13. Okay, number 5 and number 6, we're putting in the correct kind of math and our equal sign. So number 5, Katie has 7 pens. There they are. There's the 7 that she already started with. Then she buys some more pens, which we're calling P. It doesn't tell us how many she buys, but she buys some more. So she's getting more. We're adding. So she's starting with her 7, and then she adds however many she bought at the store. And now she has, means at the end, altogether, equals 18. All right, number 6. Phil has 12 grapes. There's the 12. He gives an equal number. Gives an equal number. That sounds familiar. That sounds like up here, shares equally. If he's giving out an equal number, then we're going to be doing division. He starts with 12. He gives them out equally, G grapes, to each of his 3 friends. So equals. That's how many, when I do this math, how many each of the 3 friends are going to get. Okay, number 7. We have to do 3 different things for number 7 and 8. We have to model, which means draw a picture. We have to write an equation, so we have to change the words into math. And we have to tell what the variable represents. Okay, so John has some toy cars. Does it tell us how many cars? No. So that's where my variable is going to come in. I just get to make it up. I'm going to call it T for toy cars. And look, tell what the variable represents. If I write the T right on top of this toy cars, then I know that T stands for toy cars. So John has some toy cars T. Here's the T that he's starting with. His father gives him 5 more cars. So he's getting more as addition. He got 5 more. He now has, so in all, total, after he got those 5, he now has 15 cars. So this is my expression, T plus 5 equals 15. But I'm not done yet because I still have to model. I'm going to do that over here because I don't have much room. You guys would be able to write this smaller on your paper. I'm starting with T, so I'm just going to draw a block, which I'm going to call T. That's how many he's starting with. Then I'm adding on to that T the 5 that his dad gave him. All together, both the T and the 5 added together gives me a total of 15. So my bottom rectangle has to be as big as the top 2 are together. So that's my model. I'm done with that one. Now I'm ready to move on to number 8. I'm ready to model, write an equation, and tell what the variable represents. So when the total number of crayons, it doesn't tell us the total number, it just says the total number of crayons. I'm going to call the crayon C. That's going to be my variable. When the total number of crayons C is shared equally, oh, there's some math. So here's my C, and I've got to share it equally among 9 friends. Among 9. Then each friend gets, so at the end, after I do that math, they're each going to get, that's an equals, 3 crayons. This is how I model C divided by 9 equals 3. First, I started with C. There's my C. Then, I'm going to divide that up equally, so make equal boxes, 9 equal boxes. 1, 2, 3, 4, 5, 6, 7, 8. I'll do the other one over here, 9. My boxes aren't very equally, but your picture will probably be better. And once I divide it up into 9, each of those 9 friends are going to get 3 crayons. So I got to put a 3 in each of these boxes. So see how the steps just went from left to right in math? Like I had over here on the left, I had my C, so I drew my C. Then I broke that up into 9 boxes, and then I gave 3 to each of those 9 boxes. It just went from left to right. Pretty easy. All right, so we're done with page 1 already. Let me get page 2 in here. And let's look at this question. Now they give us choices, and we have to change these words into the math expression. So, Mandy reads 72 pages of a 200-page book. Then, so we'll just say she does that on Monday. Then on Tuesday, she reads 39 more pages out of that same book. Which numerical expression shows how many pages she has left to read? Well, I've got to start with the 200 because that's how many pages are in the whole book. And then if I'm reading them, that means I'm taking that out of the total that I have to read. She read 2 different amounts. She read 72 on Monday, and she read, I'm sorry, I'm trying to see, the numbers are small, and she read 39 on the next day. So I have to add those 2 together because these are how many pages she read all together, and subtract that from how many we started with. So 200 minus 72 plus 39, and that's C. Okay, number 10. Russell has 8 video games. Here's his 8 that he's starting with. He sells some. If I'm selling, I'm getting rid of some of them, so I'm subtracting them from how many I started with. He sells some of his video games. We don't know how many the sum are, so it tells us use G. He sells G. Now he has, that tells me at the end, in total, he has, that's an equal sign, 2 video games. So I've got to look for 8 minus G equals 2. 8 minus G equals 2 is here at G. Number 11. I'm going to make this a little bit bigger, see if we can see this a little bit bigger here, guys. It's not letting me. We'll just go on the way we were then. Tiffany has 6 pairs of socks in each of 2 drawers. 6 pairs in each of I know is multiplication, 2 drawers. Then tells me I moved to my second step, so I gotta make sure I put my first step into parentheses. Then she wears 1 pair of the socks. If she's wearing them, she's taking them out of the drawer and putting them on her feet, so that's minus 1 pair of socks. So we gotta find this expression over here. Only problem is I don't see 6 times 2 anywhere. But you guys know that in multiplication, we can switch the numbers around and multiply them in any order and still get the same answer. So if I switch this around, then it would read 2 times 6 minus 1, which I do see over here as A. Okay, number 12. We got to find which one of these models matches the words. Jack and his 6 friends. I'm going to stop right there. I'm going to tell myself Jack and 6 friends gives me 7 friends total. All 7 of those friends have to buy tickets, T for tickets, to a basketball game. Each ticket costs some money. We don't know how much money, so that's why we have that variable T. Together, the tickets cost $42. When I see that word together, I know that means that's what it's going to equal all together at the end. It's going to equal $42. So I have 7 tickets, and each of them cost T. So 7 times T equals 42. So let's see if I can find 7 T's, and all of that is the same as 42. Nope, here I just see 1 T and 7. Here's 1 T and taking away 7. Here's 7 boxes, but that's saying they cost $42 each ticket, and we want them to add up to 42 tickets, $42 in total. So this one has got 1, 2, 3, 4, 5, 6, 7. Yep, there's my 7 T's. And then that whole thing, all those 7 T's equals 42. So I matches my math words. Okay, moving on to page number 3. Let me get it over here for us. Page number 3. Same kinds of things. We just have to pick the correct answer, and we have to transfer the words into math. So there are 8 people on the bus. We were starting out with 8 people on there. Then some of the people get off. Some of them are getting off. We don't know what the some are, but it looks like they're using the variable C. So if they're getting off, that means they start with 8 and some of them go away, so I'm subtracting C. Which expression shows the number of people still on the bus? Well, all I have to do is find this 8 subtract C over here in my choices, and it is C. Okay, number 14. Science class lasts a total of 56 minutes. This whole 56 minutes is what I spend in science class. Students spend 40 minutes of that time, so I'm going to show 40 minutes of that time doing lab work. The rest of the time they're cleaning up. We don't know how much that is. I'll use a C for clean up. So this amount of time in the lab and this amount of time cleaning up, so this amount of time in the lab and the time that we spend cleaning up equals a total of 56 minutes. So, which equation can be used to find how long it takes to clean up? Well, here we've got our model, here we've got our equation. I just have to match that over here, and it's going to be F. 40 plus C equals 56. Number 15, moving right along. Freddie has some granola bars. We don't know how many, we'll just call them B. He shares the granola bars equally. We know shares equally is division. He's sharing it equally among 7 people. And then each person eats. So if they're eating, well, first let's do this and then. And then tells me I'm moving on to my second step, so I better put my first step in parentheses. So, and then each person eats. If they're eating, they're taking it away from what they had, right? They're eating 2 granola bars. So I just went through the words one sentence at a time, wrote them down into math, and now I've got to find this math over here in my answer. B divided by 7 minus 2 is right here, B. Okay, number 16, they give us an input-output chart. Now, it's very important to pay attention to the letters. They call all of these numbers P, all of these numbers at the bottom Q. So when we're looking at our choices, we got to make sure that we're doing the math to the correct number. So in F, we've got to be doing the division into 12, not 3, because it said Q. And G says multiply Q. And H says divide P. So then when we move up and do the math to the 3. And I says multiply P. So we'd go up and do the math to the 3. So I can ask myself, what do I do to 3 to get to 12? And then I can find that answer down here. Or if I don't know how to do that, I can just do this math one by one. I'm going to do that. Divide Q by 3. So I look up here and I see that Q is 12. So if I divide 12 by 3, I get 4. Well, 4 isn't the same as 3, so that can't be correct. So let's see if I multiply Q by 4. So I multiply 12 by 4. I definitely do not get 3 when I multiply 12 by 4. So that cannot be correct. So H, divide P by 3. So here's my P. It is a 3, and I have to divide it by a 3. 3 divided by 3 gives me 1, not 12. So that's not right. So if I multiply P by 4, so I've got to multiply the 3 times 4. 3 times 4 does give me 12. So finally we found one that works, I. Now, just to be sure, I would go through and do the same math to all the others. I would take 4 and multiply it by 4. 4 times 4 does give me 16. 6 times 4 does equal 24, so that's correct. And 7 times 4 does equal 28. So, yep, I checked my work. I am right. Okay, one more page. We are almost done. All right. We have a pattern here. We have to see what they're doing to the pattern. So I asked myself, what do I do to 50 to get 45? Or what do I do to 45 to get 40? What do I do to 40 to get 35? And so on and so forth. That one's pretty easy to see. All I'm doing is taking away 5 each time. All right, so which number sentence shows the distributive property? In Chapter 3, we learned all kinds of properties. We learned the associative, the commutative, the identity, the zero, and the distributive property. So you would either need your book if you don't have them memorized, or you would need to go online to Think Central and go back to the first couple of lessons and see what these properties actually are. But I'm just going to go through every one of them. I'm going to tell you what property it is, and then we'll find which one's the distributive property that way. So F, they've got 2 times 3 equals 3 times 2. All I did was switch the numbers around. That's called the commutative property of multiplication, not the distributive. All right, number 2, or G, they have 3 times 7 equals 3 times 5 plus 3 times 2. So what I'm seeing they're doing here is they're taking their 7 and they're splitting it up into a 5 and a 2, because 5 plus 2 is 7. I think they're doing that to make it a little bit easier on themselves. Maybe they don't know what 3 times 7 is. So they're breaking that 7 up into 2 smaller problems because they know how to multiply by 5 easily and they know how to multiply by 2 easily. Guys, when you take a number and you break it up into smaller problems, That is the distributive property. You're distributing that number out into two other problems to make it easier on yourself. Distributing is the same as breaking it up. Okay, keep going though. Let's look at these other properties. 5 times 0, that's probably the easiest one. That's the 0 property of multiplication. Then here they've got 3 times 7 times 4 equals 3 times 7 times 4. Same numbers, same order. All they're doing is they're moving the parentheses to different places. That's called the associative property of multiplication. The only one they didn't show us up here that we learned was the identity property. And the identity property is anything times 1 equals itself. All right, number 19, last one. They give us a pattern here, and they say Patty makes the pattern of buttons that are shown. If she continues this pattern by adding another row at the bottom, how many buttons are going to be in the bottom row? So not in the whole thing, but just the bottom. So we got to look and see what she's doing so we can continue the pattern. Here she's got 2, 4 buttons, 6 buttons, 8 buttons. This is a pretty easy pattern to see. All she's doing is she's adding on 2 buttons to every row. So I can draw my next row, add on 2 buttons, and count them all up. Or I could just take the 8 and add on 2 more, and I get 10. So we know in math you have to write it way over here on the right-hand side and then fill in the bubble for the numbers. 10 is our answer if we would continue that pattern. All right, guys, so that's the end of the chapter review for Chapter 3. If you have any questions or you're struggling with a certain problem in particular, just go ahead and leave a comment, and I will try to get back to you or your student in class. Thanks.